Hi to all. In this video, we are going to see about a design of armature slot dimension. Okay, so the armature windings can broadly classify into concentrated and distributed winding. Concentrated in the sense the coils which will be wounded in a particular area. Okay, distributed winding in the sense that coil will be spreaded all over the machine. Okay, that is distributed winding. In case of a concentrated winding, all the conductors per pole is housed in one slot. Okay, since the conductors per slot is more, quantity of insulation in the slot is more, heat dissipation is less, temperature rise is more, and the efficiency of the operation will be less when you go for concentrated type of wounding. Okay, will be less. So also EMF induced in the armature conductors will not be sinusoidal. Therefore, we should go for a distributed type of winding. Okay, design calculations becomes complicated. Okay, when we go for concentrated one, because of the complicated expressions of non-sinusoidal wave. Okay, core loss increases because of the fundamental and harmonic components of the non-sinusoidal wave, and efficiency reduces. Okay, communication interference may occur because of the higher frequency components of the non-sinusoidal wave. So we should not go for a concentrated type of windings. We should go for distribution type of winding. In a distribution winding, okay, hence no concentrated windings is used for the practice of a DC machine armatures. So in a distributed windings used to overcome the disadvantage of concentrated windings. So concentrated winding means what will happen? So it will produce more heat, and it will produce non-sinusoidal waves, and to overcome that we are going for distributed type of windings. In a distributed windings used to overcome the disadvantage of concentrated windings. Okay, so conductors per pole is distributed in more number of slots. Okay, the distributed winding can be classified as a single layer winding and double layer windings. Single layer in the sense, in a slot we have wound only one winding. If it is double layer winding, we should wound two times. Okay, single layer winding, there will be only one coil side is in slot having any number of conductors, odd or even integer, depending on the number of turns of the coil. In a double layer windings, there will be a two or multiple of two coil slides in the slot arranged in two layers. Okay, obviously conductors per slot in a double layer winding must be an even integer. Okay, so is a coil, single one coil of a coil, one coil side of a coil having any number of conductors or turns per coil. Single layer winding, single coil will be wounded. Two coils per slot. Okay, this one, and this will be four coils per slot, and this will be the double layer winding. It's a double layer winding, double layers. It's a upper layer and a lower layer. Okay, so here only single layer. Since for a given number of conductors per pole, poles and slots in a single layer windings calls for less number of coils or more number of turns, reactance voltage proportional to is high. This decreases the quality of the commutation or leads to sparking commutations. Hence, a single layer winding is not generally used in DC machines. When you go for single layer windings, that commutation sparking will be occurs. So to overcome that, we are going for double layer windings generally. Okay, however, it is much used in alternators and induction motors where there is no commutation involved. Okay, in a DC machines, we will not go for single layer winding. In the case of AC machines, we will go for single layer winding because there is no commutations are needed in that. Since a double layer windings are called more number of coils or less number of coils, number of turns per coil, reactance voltage proportional to turn square is less and quality of commutation is good. Hence, double layer windings are much used in DC machines. Unless otherwise specified, all DC machines are assumed to have double layer winding. Okay, a double layer winding can further be classified simplex and duplex windings. Simplex or multiplex or duplex. Okay, and lap or wave windings. In order to decide what number of slots is to be used, the following merits and demerits of we consider number of armature slots. Okay, as the number of slots increases, the cost of punching the slot increases, the number of coils increases, and hence the cost of the machine increases. When we go for number of slots more, then the punching will be more, and the coil increases, and the cost of the machine. As the number of slots increases, slot pitch lambda s is equal to slot width bs plus tooth width bt. Okay, decreases, and hence the tooth width reduces. This makes the tooth mechanically weak. Okay, so increases the flux density in the both tooth and the core loss in the both. Okay, therefore efficiency of the machines decreases. Okay, if the slot are less in number, then the cost of the punching and number of coils decreases. Slots pitch increases, tooth becomes mechanically strong, and the efficiency of the increases. Quality of insulation is the slot increases, heat dissipation reduces, temperature increases, and hence the efficiency decreases. It is clear that the not much advantage of gained by the use of the either too less number of slots and too high number of slots. As a primary value, the number of slots can be selected by considering the slot pitch. The slot pitch can be assumed to be 2.52 and 3.5 centimeters. This range is applicable to only to medium capacity machines, and it can be more or less for the other capacity machines. The selection of the number of slots must be also be used based on the type of windings which is used in the motors. When the number of slots poles, the number of slots embraced by each pole will be the same for portions of the armature. However, the number of teeth per pole will not be same. Okay, so this causes variations in the reductance on the air gap, and flux in the air gap pulsations of the flux in the air gap produces iron losses in the pole shoes and gives rise to magnetic losses. Okay, so on the other hand, when the slots per pole is equal to the whole number plus half of the reductions of the flux constants remains constants for the position of the armature, and hence there will be no pulsations or oscillations of the flux in the air gap. To avoid pulsations and oscillations of the flux air gap, the number of slots per pole should be a whole number. Okay, so here we can see pole shoes and number of slots. The number of teeth per pole shoe is equal to 5. See here, per pole shoe, number of teeth will be 5. Okay, through the teeth. The reluctance of the hair gap is inversely proportional to the area of corresponding to 5 teeth. When you come for this diagram, is 6. Okay, there are number of teeth per pole is 6 flux per teeth will be armature is moved. Okay, of tooth pitch to the right. The reluctance of the air gap inversely proportional to the area of corresponding to 6 teeth. Okay, so pole shoes, the number of teeth per pole shoe is equal to 5 plus 0.5 flux path. 6 teeth when the armature is moved off tooth pitch to the right. The reluctance of the air gap is inversely proportional to 6 teeth as before. The reluctance and the flux in the both the cases remains the same position armature. Okay, so to obtain the good commutation, the flux density in the air gap must be decreased gradually from maximum value to the minimum value poles. Okay, 2 poles, and flux densities near the neutral points must be low. Okay, so lambda is equal to pole arc by pole pitch, that is the value will be less than or equal to 1.0. In practice, lambda lies between 0.6 to 0.7. Okay, so in general the slot between the pole tips of two adjacent pole tips, that is 1 minus lambda into s by p, should be at least 3, or 1 minus lambda s by p is greater than or equal to 3. If lambda is equal to 0.66, it's a default value. If they are not given the value of lambda value, we should consider as a 0.66 is a lambda value, the number of slots per pole. So s by p is greater than or is equal to 3 by 1 minus 0.66, that is the value will be greater than or is equal to 8.82 or say 9. Okay, so number of poles, sorry, number of pole that The flux, to obtain the good communication, the flux density should be, air gap must be decreases gradually.